How are you? And now we'll be collecting in. Yeah, we've been pretty settling. But I'm about to quit. iPad. All right. What do you prefer? So I feel like what you pick. Yeah. Like in the cupboard or they in the bag? Huh? Come, baby, come, baby, come. Stop. Textbook away. We are in the Okay. Right. So the visibility, a reminder. Okay. If we're doing an induction proof by the visibility, like the other proof, what's our first step? If we were to prove what A is equal to 1. So in this example, okay, when we just divisible by 6, so we said the 6 is divisible by 6. Then we assume true for any equal to K. Now with the other sums, immediately we just write required to prove and we're done with our condition. With the visibility, there's more work to be done. You want to isolate a power in your assumption. Yes, we did. I'm just reminding you. Okay. So we assumed, okay, true for n is equal to K. So that's divisible by 6. Now, if something is divisible by something, when you divide it out, you get a natural number as the answer with no remainder. So we made this assumption over here, and we said, okay, this is equal to P. Okay, where P is some natural number. Okay. And then if I times it out, I get that. But remember what we wanted to do is isolate a power. That now becomes your big star digit. Okay, and you're going to stuff that in the statement on. Tremendous, right? Then we go to what we're trying to prove. Okay. And we're trying to show that that's divisible by 6. How do I ultimately show that it's divisible by 6? Then I can take out 6 as a common factor. If you do that, then it is divisible by 6. Okay. So, right. Okay, so then this becomes, so we had to force the assumption, which was 7K into the sum. So we did that over here. We forced in the 7K was equal to 6B plus 1. And then we hope like hell that we can take out 6 ultimately as a common factor, which we could. And then we go to the whole by n. That is the whole divisibility proof of induction. But let us do another one now. Okay. And the next one is it's Friday. Prove using induction that n squared plus n is even for all n is elements of maximum. Okay, well, if you put in any number, put in 999, let's see if it's working. So 999 squared plus 999. It works, yes. Okay. That's how we're going to go about that. So the question is saying, honey, now, okay. So the question is saying, is it divisible by 2? So that that's what you're trying to do. Okay, something is even number, we're trying to show it's divisible by 2. Division. There. Okay. So required to prove is going to be what? N squared plus N is divisible by 2. But okay, well, you don't have to write that down now. I'll focus mine. So, Rosie, the face a little bit like her little friend over there. Right, that's better. Okay, so Rosie, what's the first thing we have to do? Show it's true for? Okay. There's no left-hand side and right-hand side now, guys. You know that workshop is on. Right. Okay, you do accounting. Okay, right. So n squared plus n is 1 squared plus 1, which is equal to 2, and 2 divisible by 2. So therefore, it is true for. Thank you so much. Okay. So, yes. What do I do next? Okay. I assume true for n is equal to k. K is an element of the natural number. Okay. I.e., we assume k squared plus k is divisible by, you have to write this line. Yeah. I would do. No, you can skip that. I would skip that. I would go straight to. I would actually. I would probably leave that out. K squared plus k over 2 is equal to t. And what type of t is this? Say k squared plus k is equal to 2t. We'll stop there for now. You might adjust this, just go back and adjust it. True for n is equal to k plus 1. I'd like, I'm not quite sure if we're going to have to, I'm going to just see, but this is going to be our little. Well, I might get k squared, and I'm going to see what happens. Go back and have a look. Let's find the k squared first. Okay. Right. So I've got to prove it's true for n is equal to k plus 1. In other words, I've got to prove, go back to the original question, which was prove that k plus 1 squared, k plus 1 squared plus k plus 1. No. I've got to show that this is divisible by 2. I don't write that as, I don't write this part of it. I use the assumption I do that. Now, what's my objective? Okay, what's my aim? I want to be able to use my substitution and show that I can take out what? 2 as a, so we want to take out, show we can take out 2 as a common. So that's my objective now. I want to be able to take out from this sentence. I want to be able to take out 2 as a common factor. Why? Because that shows that it's divisible by 2. You with me? I'm not going to write that, but we're not assuming it's a robot, so I can't put that is equal to 2 over P. Okay. The only thing where we do that is an assumption. In the assumption, we do that. In the proof, we don't do that part. We're going to have to sub this in somewhere.
So I'm just asking.
Well, only know this bit over here I wrote up because the question said, didn't say show us if it's all by 2, it said show that it's even.
Oh,
I'm not just trying to explain that so that even we're going to show that it's divisible by 2. That's not right. Yeah. Yeah, okay. So, so I left it like this, but probably we might have to always leave a bit of space here in that assumption with this divisibility question, because I might go have to figure it out. I get K squared on it. Okay? So, so here's the proof. Okay, right. So, Zoe, what are you going to do first? In this one over here, we're going to have to times out, right? Okay. So if I times out, I get K squared plus 2K plus 1 plus K plus 1, right? So that's K plus 1 squared plus K plus 1. Okay, so now, the thing is, I don't have a K squared plus K here, so there are various ways you could do it. You could actually just rearrange it with K squared plus K. Likewise, you could just say K squared is equal to 2P minus K. It's not going to make any difference. Okay, so I'm going to sub in this. Right, so go sub in that and see if you can end up taking out 2 and put it back. It could, you could do that. It would work. It would work. Okay, so the same thing here. So you could rearrange it and say K squared plus K plus 2K plus 2. And then you could replace K squared plus K with 2P. Let's do that. Make a note though. Okay, so I'm going to just use this one then. Okay. Start. Okay. So if I sub in K squared plus K is equal to 2P, it becomes equal to 2P plus 2K plus 2. And what is wonderful about that, Voyager? What can we do? We can take out. What's the name of the thingy? Ooh, that's the name changed from yesterday, didn't it?
Yes.
I'm saying the same thing.
No, hip is a big, it is. Oh, that is a pig.
Hip is a hippo.
Yes, I thought it
Puma is a pig.
was, it's fully with the gray.
And what is Puma that? Like, the one star
Like,
or
no, the first one, this one.
not a Puma actually. Okay, right, okay. So I take out 2 and I'm left with P plus K plus 1. Okay? Therefore, true for anything equal to K plus 1. Therefore, true for all natural numbers. Okay. I would just accept that. Okay. Yeah. No, but I would write that. I think that you can. Is there many 14 and 15? You have to write it in the code.
Yes, we'll go there.
That's your. What's the last? What's not going to be 32 anytime soon?
No.
No. I'll see you well. Not scratch your horse into a sleeve. Make it feel. Lost. What law does that use? Okay. All right. Everyone give the person next to you a bit of a slap. Wake up slap, please. Give them a slap. Give them a slap. Hey, little cow, give her a slap. Little cow. Slap that girl now. Right, okay. Right, next one. Okay, that's fine. No. Keep the tail screwed up. Right, I'm back. Right, okay. Right. Okay, so now we get into a bit more complicated, but hey, I think, hey, right, shoot the stuff. Yeah. Okay, let's do one more, then we still have break. Okay. Okay. Right, so the question says, prove that 5 to the 3n minus 2 to the 5n is divisible by 31 for all n is an element of natural number. Right, so your first step is what, Eva? To show that it's true or right. Okay. Problem taken. 93, eh? Um, Sure, with a good run away. Eat, run. Okay, right. Right, Alison, what is next step? Right. In other words, Bria, what do we assume? I.e., assume. Were you, I can't remember, were you in a class last year or were you opt out?
I was in the class, I was in your class again too.
And then I kicked you out.
Yeah.
Get out. Yeah?
Yeah. So I think
And then we use the cell software. Right, so we assume that this is divisible by 31. Right? Yes. So we assume, okay, so we assume that this divided by 31 equals where P is a natural number. So now, guys, we have to isolate. But appreciate like P. Right. Oh, and K. No, this is not K. Yeah. Right. We put P is an element of the natural numbers.
In brackets or semicolon.
K is an element of integers when we do two equations. Okay. All right. So now the question is, which power do I isolate? And the answer is it does not matter which one. Pick one. Okay. Pick a power, any power. Let's all pick 5 to the 3K. Let's get that on top. Take 5 to the 3K. or. Yeah, doesn't matter, but I'm gonna pick 5 to 3K from the top. Still our assumption, eh? 5 to the 3K is equal to 31p plus 2 to the 5K, eh? Yeah. And that is going to be our little sine stuff. Lovely stuff. Right. Now, what is next step, please, road jump? Is this brunch? What are we talking now? I don't know. I don't understand. I can move. Reply to group. Yes. Hi. Fluffy. What are we trying to prove in this particular case? We're trying to prove that 5, 3 times k plus 1 minus 2, 5k plus 1 is, no, man. In the proof, we don't do that. Okay. Sorry, just fluffy. Okay. You're going to have to kill this cow. It's divisible by 31. Although I think you're thinking it might make a change. Right. So what do we have to do? Somehow we have to force 5 to the 3k into that term. Okay. Okay, so Milos, tell me. Okay, so you can skip up the step I'm doing it. Yeah. So it becomes 5 to the 3k
Times 5 to the 1.
times 5 to the, don't forget, times 5 to the 3. Okay, minus 2 to the 5k times 2 to the 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 2 to the. Can I get an answer, please? Right, thank you. Okay. I think again. Okay, so what's our objective? Objective, we won't be able to take up this one as common sense.
Oh, no.
What an attitude to have, Alison. Okay. That's incorrect, isn't it? So we get, well, 5 to the 3 is 125, right? So you call 5 to the 3k is 31p plus 2 to the 5k times 125 minus 2 to the 5k times the 5 is 52, eh? Right. And we looking to take up. Right, pause. What are we looking to take up? 31. Come on, I'll give you a minute.
Why don't you take up 2 to the 5?
Engage with your neighbor. have a look. Right. If you have 125 chickens, right? And you minus 32 chickens, those are like terms. Those are like terms. They're like terms. 2 to the 5, you've got 125 lots of 2 to the 5k, minus 32 lots of 2 to the 5k. Yeah, of course you can. Okay. Because you try and take out 31 as a common factor. So I times that in. Okay, and I got 125 times 31p. That's when I did this, right? So that's what that was. Then I times 125 by 2 to the 5k. And 2 to the, right, you happy with that? I said 31p times 125, right? That's the switch here in yellow. So when 31p times 125 is that. 31p times 125 is 125. Why do I leave the 31 there? So what am I trying to ultimately do? Take out 31 as a common factor, right? Then I went, okay, 2 to the 5k times 125 is 2 to the 5k times 125, right? And then I've got this bit over here, which is minus 32 lots of 2 to the 5k. So if you had 125x minus 32x, what would you have? You'd have 93x. So 125 lots of 2 to the 5k minus 32 lots of 2 to the 5k is how many 2 to the 5k? 93. So you've got 125 lots of 31p plus 93 lots of 2 to the 5k. What was our objective? We want to take out 31 as a common factor, right? Okay, that's 31 going to there. Okay, that's 31 going to there. Yes, because 93 divided by 31 is, right, so go back to take out 31, yeah? It was the same thing. 125 minus 32.
That would give you 21p plus 25k open bracket 125 is 5 minus 32. Give you 31p plus 25k times 93, and then you take out 31 and you get 31p plus 25k times 3.
Sounds right to me. Okay, so now I take out 31, and what you left with? 125p plus 3 lots of 2 times 5 to the k. Okay, so therefore divisible by 31 when n is equal to k plus 1. Therefore, through no, because you have to boil that up. No. This step from here to here is wrong. That step's wrong. Because what? There's no common factor. If you say you can't back out, Sum is back up. You get 5 to 3 pieces 5 times X minus 5 to 3 pieces 5 times X. So from here to here is again, that's your problem. Okay. You're on your break. 11:45 we got. So you all being nice to math teachers.
So,
Just asking.
Yeah.
By the way, you cannot use, I think this is where you had some, cannot use the virtual light net as a reason. No, I'm not, it's not a fault, indeed you can, right. So, listen to me. Okay, you have to write that full sentence. Okay, every element of an array starts, what's the key word for showing that it is a function? It starts to a single element in the array. Okay. No, it's all over your notes. But you tell it, so you tell it to your. Every element of the day is supposed to be a single element. Vertical line test and horizontal line test are methods, they are not even.
no, I said,
I'm not getting your answer. But then, yeah. But we're following you on shopping, put it in. And you let go, they'd be like. Ah. Probably has more energy in the break than it does in the. I think you favorite thing. So I put them years ago when I was like, but I was pretty trendy with them. All right. Right. Okay, let's go. Let's get started. Right, put it away. Put it away. Right. Okay. Time to stop the next time. Let's keep going. Right. The same equal to x minus one. I will stop there and say therefore true for any digit. Okay.
Do you mean you can stop after the x times y with x times y?
And I would even write that really. I'd say when n is equal to one, I would what thing? X to the a minus y is equal to x minus y, therefore it's true. I would just write that little bit over here. X minus y. Okay. Right. You need to stand up for yourself. Right. Vector. Okay. Speak about. Okay, right. Come on, try yourself, my guy. Do more with that assumption. Yeah, let's see. Okay. I wouldn't pull that out, but I'll just get X to the cat of close for now. Yeah, you can, I'm sure you can. So you have to be happy after this. Hang on. Right, so you have to show you can take out x minus y as a common factor. That's your objective. You want to take this expression and take that expression and show that somehow you can take out x minus y as a common factor. To do that, you're going to have to use substitution.
No, actually, no.
How you do? Substitute is,
It's not fair.
yeah. Okay. Okay, so what did you do first?
I needed-
Hang on. X to the k plus 1. Rosie. Y to the k plus 1 is equal to your with
expression.
Okay, good.
Five zero. Six months, Y. Yeah, Y.
We're going to sum up this. The sum is now. So you said, Milot, on the sum x to the k in, you got x to the k was equal to x to the k will be popping out, eh? Is equal to y to the k plus t x minus y. I'm going to times that all by what? By x. Okay. Then after what? Minus y to the k times y.
Yeah. So then this will be going to start off.
This is my next one. Okay. So now we're looking to what's our objective? We want to take out x minus y as a common factor. So I would not times into that. I want that x minus y, but I would distribute this. So I times x by that, and I times x by that. Into that bracket.
Yeah.
So you know something's going
Oh,
to
you
be.
trying to.
Yeah, because it's that times, because x times this whole thing, right? But you got times x, you got to times x,
You're not trying to put a P.
but it's distribute x into that term and into that term. So yes, so what's going to become? X times yk is x times yk, right?
Then you could just
Plus
get X T.
tx
Okay, yeah.
times x minus y, right? You want to keep that x minus y there, why? Because we're going to take that out as a common factor, right? So what we still got? So now, well, this term is fine. We've got an x minus y. So somehow I've got to pair up these two, be able to take out x minus y as a common factor. But is there a common factor amongst those two groups? So go take out y to the k. Or you can think of it as adding like this. But if you agree with me, if I take these two terms, you've got to focus your mind on what you're trying to do. What you're trying to do is take out x minus y as a common factor, right? So now, are you happy that with that going from there to there? Okay, so now there's two terms, and so now what's the common factor? Okay, is what I wanted. And we have just y to the k. No, not at all. Okay. Oh, you can one induction question. But then one induction 12 marks. So about 206%. Okay. Right, therefore, visible What are you doing here? Hi. Next lesson practice. On the textbook, bring your freaking textbook, make a note.
You will